Good morning students, welcome to 9th class mathematics, first chapter real numbers. We are already discussing exercise 1.2, sums we already completed. So now 8th sum, find at least two irrational numbers between 2 and 3. There are two different methods of finding the irrational numbers between two numbers. So the first method, irrational number between 2 and 3 is, we know that an irrational number between a and b is square root of a into b. Square root of a into b in that form, square root of 2 into 3, that is square root of 6. This is one of the irrational number between 2 and 3. Now we require two irrational numbers between 2 and 3. That means in between 2 and 3 we already found root 6, one irrational number. Now another irrational number between 2 and root 6. We need to find another irrational number between 2 and root 6 or root 6 and 3. So we found irrational number between 2 and root 6. Simply square root of a into b in that form, square root of a 2 into b root 6. This is another irrational number between 2 and 3. So that means between 2 and 3 there are two irrational numbers we found, root 6, and in between 2 and root 6 square root of 2 into root 6. These are two irrational numbers between 2 and 3. This is one method. In the another method, we can find many non-terminating, non-recurring decimals between 2 and 3. So, two irrational numbers we require. Two irrational numbers between 2 and 3. Now we write two or more than two non-terminating, non-recurring decimals. So, one of them is 2.12. 1 2 2 1 2 2 2 1 2, so on. This is one of the irrational number. And second one 2.23 2 3 3 2 3 3 3, so on. This is non-terminating and non-recurring. Here 2 3, here 2 3 3, here 2 3 3. This is non-terminating and non-recurring decimal. In this way, you can write any number of non-terminating, non-recurring decimals between two rational numbers. So this is one method. This is another method of finding irrational numbers between two rational numbers. Now, ninth question in exercise 1.2, state whether the following statements are true or false. Justify your answers. So first statement: every irrational number is a real number. That means if you take any non-terminating, non-recurring decimal or square root of non-perfect square numbers like that, every irrational number is a real number. Is it true or false? It is true, because all the rational numbers and irrational numbers, rational numbers means q, irrational numbers means q dash, this collection is real numbers. So all the rational numbers are real numbers, all the irrational numbers are real numbers. So this statement is true since irrational numbers are the part of real numbers. So this statement is true. Second one, every rational number is a real number. Second one, every rational number is a real number. We already discussed this. All the rational numbers and irrational numbers, this collection is a real number set. So every rational number is also a real number. This is also a true statement. If you want to write the justification, write the definition of irrational number and rational number, and or the definition of real number. A collection of rational and irrational numbers is a set of real numbers. So next, third one, every real number need not be a rational number? Is it true or false? Every real number need not be a rational number. What are real numbers? A collection of all the rational numbers. A collection of all the rational numbers and irrational number is a real number. If you take any real number, it might be a rational number or irrational number. So the statement is every real number need not be a rational number. It might be irrational number also. So the statement is true. Justification, if you want to justify root 2 is an irrational number, therefore it is also a real number. So root 2 is a real number. It is not a terminating decimal or non-terminating recurring decimal or p by q form. So it is not a rational number. Root 2 is an irrational number and real number. It is not a rational number. This is the justification for the above statement. So fourth statement, root n is not irrational if n is a perfect square. Square root of perfect square number is not irrational if n is a perfect square. This is true or false? For example, square root of perfect square number, square root of 9. Square root of 9 value 3. It is an integer. It comes under the set of rational number. It is not an irrational number. So the statement is true. Square root of n, square root of any perfect square number, square root of 4, 2, it is a rational number, it is not an irrational number. So square root of n is not an irrational number if n is a perfect square. So this statement is true. So this is the example for the justification. Square root of perfect square number is always a rational number, not an irrational number. Next, square root of n is irrational if n is not a perfect square. That means if square root of non-perfect square number, for example, if you take 3, this is an irrational number. We already found the value of square root of 3 is a non-terminating, non-recurring decimal. Square root of 2, square root of non-perfect square number, square root of 5. These are all irrational numbers. So square root of non-perfect square numbers are always irrational if this n, square root of non-perfect square number, is always an irrational. This statement is also true. Last statement, all real numbers are irrational. So let us go again the set. All the collection of rational numbers and irrational numbers is the collection of real numbers. All the rational numbers are real numbers, all the irrational numbers are real numbers. But here the statement is all the real numbers are irrational. Real numbers contains the collection of rational and irrational. All the real numbers are not irrational. All the real numbers contains rational and irrational, not only irrational. So this statement is false. Since you need to give an example, 3, otherwise 3 by 5, this is p by q form, is a rational number and a real number. Rational, all the rational numbers are real numbers. So it is not an irrational number. So all the real numbers are not irrational. There might be rational also. So this is the example. We can write any integer or any fraction or any terminating or non-terminating recurring decimals for this example. The irrational number topic. Next one is representing irrational numbers on the number line. Representing irrational numbers on the number line. Which type of irrational numbers? Square root of non-perfect square numbers, representing root 2, root 3, root 5 on the number line. So to represent root 2, root 3, root 5, these type of numbers on the number line, we use Pythagoras theorem. Do you know what is Pythagoras theorem? You already learned about Pythagorean triplets. Pythagorean triplets. Do you remember what are Pythagorean triplets? Square of sum of squares of two numbers is equal to the square of other number. Sum of squares of two numbers is equal to the square of other numbers. Those are called Pythagorean triplets. For example, if you take 3, 4, 5. Square of the bigger number, 5 square is 25. 3 square, 9. 4 square, 16. 9 plus 16 gives 25. The square of the bigger number is equal to sum of the squares of other two numbers. That means 5 square equal to 3 square plus 4 square. 25 equal to 9 plus 16. That is also 25. So if you take the three numbers, the square of the bigger number is equal to sum of the squares of other two numbers. Those are called Pythagorean triplets. Like this we can take so many examples. So this Pythagoras theorem states about the right angle triangle. Discuss about the right angle triangle. If you take a right angle triangle A, B, C, right angle at B, the side opposite to right angle is called hypotenuse. This is the longest side. You can take right angle triangle like this also. This is hypotenuse. The side opposite to right angle is called hypotenuse. This is the longest side. So using Pythagorean triplets, if you consider, if it is 5 centimeters, this will be 3 centimeters and this will be 4 centimeters. So 4 square plus 3 square gives 5 square. Pythagorean theorem states that the square of the hypotenuse square, the measurement of hypotenuse square is equal to sum of the squares of other two sides. If this is height, this is base. If you consider this is height, this is base. That is height square plus base square. So we can simply say that hypotenuse square equal to side. This is one side, this is the other side. Side square plus side square. So Pythagorean theorem states that the square of the hypotenuse is equal to sum of the squares of other two sides. For example, if you take 2, 3, what is this value? So hypotenuse. This is hypotenuse. Hypotenuse square equal to side square plus side square. 3 square, 9 plus 2 square, 4. Total 30. Hypotenuse square equal to 30. What is hypotenuse? Hypotenuse equal to root 30. To remove square, we apply square root on both sides. These two will be cancelled. Hypotenuse equal to root 30. This value is root 30. So using Pythagoras theorem, we represent these irrational numbers on the number line. So to represent the root 2, one side and another side we need to take. We represent the root 2 as hypotenuse. What will be the other two sides? We should find what are the remaining two sides. So we need to find the remaining two sides. Then we represent root 2 or root 3 or root 5 or some of the other irrational numbers. Square root of non-perfect square numbers on the number. So if it is 1, hypotenuse square equal to side square plus side square. Hypotenuse square equal to side square plus side square. If you need to find hypotenuse, apply square root on both sides. Square of side square plus side square. That is, if it is 1 square plus 1 square. 1 plus 1. That is square root of 2. So first we need to find what are the remaining two sides to represent the hypotenuse. So using this Pythagoras theorem, Pythagorean triplets, we represent irrational numbers on the number line. So first example, represent root 2 on the number line. Represent root 2, first irrational number, square root of non-perfect square number, root 2 on the number line. To represent root 2 on the number line, first we need to draw a number line, integer number line. Integer number line with unit space. Draw a number line. You can take like this 0, 1 as on the scale, otherwise you can take 0, equal space 1, this is 1 unit. same equal space 2, same space 3. Otherwise you can take the numbers, you can represent like this on the scale 1, 2, 3, 4. It should be unit space, same space, equal space, like this negative numbers -1, -2, equal space. So we need to represent root 2. Root 2 lies between two integers. What are those two integers? Root 2 value lies between which two integers? So to find this, we use Pythagoras theorem. By Pythagoras theorem, in a right angle triangle, if you take root 2 as hypotenuse, what will be the remaining two sides? Hypotenuse square equal to side square plus side square. Hypotenuse equal to square root of side square plus side square. What will be the remaining two sides? So if this is 1, this is 1. Hypotenuse equal to square root of side square plus side square. 1 square 1 plus 1 square root of 2. So if you want hypotenuse as root 2, we need to take remaining two sides as 1 and 1. So for this, we draw a right angle triangle or a square on the number line. Take this as one unit, one base. In the right angle triangle, this one unit is this. We need to represent this height, perpendicular line, perpendicular height 1 on the number line. How to draw perpendicular line on the number line? You can use the protractor. Perpendicular line means which makes an angle 90 degrees. Otherwise, you can use this set square, perpendicular line. Otherwise, we can draw using compass also. Right angle using compass. We already solved in the 8th class. Simple method is using this set square. Place the base on the number line like this. Draw a perpendicular line to draw a right angle triangle. So this is a perpendicular line. So if this is 1 unit, this is also 1 unit. This should be 1 unit. This is not 1 unit. This is more than 1 unit. So for this, we use compass. Measure this 1 unit. This is 1 unit. Cut the right angle, the gray as 1 unit. This is 1 unit, same measure. So this is 1 unit. This is also 1 unit. So if you join these two, for example, this is A, this is B, this point is C. Join A and C to get a right angle triangle. Join A and C. So by Pythagoras theorem, the side square plus side square gives hypotenuse square. So hypotenuse equal to square root of side square plus side square. That is 1 square 1 plus 1 square 1 square root of 2. This measurement is square root of 2. AC measurement is square root of 2. But we need to represent this root 2 on the number line, not on the right angle triangle, on the number line. So measure the distance between A and C. Draw the arc on the number line. It cuts the number line between 1 and 2. So this point is root 2. The distance from A to this point, for example, this is P. A to P is root 2 units. This distance is root 2. So root 2 lies between 1 and 2. Root 2 value lies between more than 1 and less than 2. So this is the representation of root 2 on the number line. So for every different number, we need to calculate using Pythagoras theorem and we solve on the number line. This is representing root 2 on the number line. So next example, locate root 3 on the number line. So using Pythagoras theorem, if you want to locate root 3 on the number line, what will be the sides? So that means hypotenuse is root 3. What will be the base and height? So take this base as root 2 and height as 1. Otherwise base as 1 and height as root 2. How do we know this base as 1 and height as root 2? So hypotenuse square equal to side square plus side square. Here hypotenuse is root 3 square equal to side square plus side square. Root 3 square means 3. 3 means 2 plus 1 3. Hypotenuse square equal to side square plus side square. Here square of the side is 2, square of another side is 1. So here root 2 square equal to 2, 1 square equal to 1. So that means the square of the hypotenuse equal to square of 2, square of root 2 plus square of 1. That means one base is 1 and height is root 2, or height is 1 and base is root 2. We can take anything like this. So draw a right angle triangle, take hypotenuse as root 3, identify base as 1 and find height using this Pythagoras theorem. So height will be root 3. That's root 2. Root 2 square plus 1 square gives root 3. Root 2 square plus 1 square gives 3. Root 2 square means 2. 1 square means 1. 2 plus 1 3. But we need square of the hypotenuse is 3. The square root of the hypotenuse gives root 2 square plus 1 square. That means base is 1, height is root 2. To locate root 3 on the number line, first we should represent the root 2 on the number line. Then we go for root 3. Again root 2 on the number. Take unit space 1, 2, equal space 3. You can use scale also. So like this scale 0, 1, 2, 3. You can take on the notes. So now to represent the root 2, base as 1, height as 1, this will be root 2 units. So we need to represent height 1 using set square. Now I am using protractor. Using protractor, place the center of the protractor at 1 and represent 90 degrees. Remove this and join these two. This is 90 degrees. We need to cut this 90 degrees ray as 1 unit. This is 1 unit. Cut this as 1 unit. So this point. This is A, this is B, this is C. Join A and C using scale. This is root 2. This is 1, this is 1 root 2. Now to represent this, take this base as root 2 and height as 1. That means already this base as root 2. Now we need to draw a perpendicular line, measurement 1 unit on this root 2, on this base. So to represent 1 unit perpendicular line, take protractor. Take this as base and place the center of the protractor at point C and 90 degrees. Join those 2 points. This is the perpendicular line. This is root 2. We need 1 unit height. So to draw 1 unit height, this is 1 unit. 0 to 1 unit. Cut this perpendicular line 1 unit. This is 1. Root 2 square plus 1 square gives 2 plus 1, 3. Square root of root 2 square plus 1 square gives square root of 3. So this is taken as P. Join these 2 points A and P. This is root 3 units. But we need to locate root 3 on the number line, not on the right angle triangle. So measure this root 3 units. This measurement is root 3. Using this radius, extend this arc on the number line. This point, you can name with any letter Q. The distance between 0, that means A and Q is, this distance is root 3 units. So root 3 also lies between 1 and 2. This is root 3. This point is root 3. So to represent root 3 on the number line, first we represent root 2 on the number line. Then we draw a perpendicular line using root 2 as base and draw a perpendicular line. We draw an arc with 1 unit measurement on the perpendicular line. We join A and P. So this will be root 3 units. Using this radius, we draw an arc which intersects the number line, that integer number line. So we can locate root 3 on the number line using Pythagoras theorem. So today's assignment is for practice. Locate root 2 on the number line, root 3 on the number line. Draw perpendicular lines using protractor or set square. Or you can use a compass also for drawing perpendicular 90 degrees angle. So locate root 2 on the number line and root 3 on the number line using Pythagoras theorem.